All right, well, let's get started on lesson 4.3. Lesson 4.3, we're going to talk about a unit circle. So we've been dealing with triangles. Today we're going to see something called a unit circle. Before we get going, just make sure you have gone to classwork on your digital classroom or Google and scroll down to lesson chapter 4 and then open up 4.3. You right now are accomplishing number 1. There's 4 things for every lesson. You're accomplishing number 1. You're either signed into Zoom, you might be listening to me later through the YouTube playlist, but either way, or you might be in class. Thank you, Jose. You've taken care of number 1. Number 2, this attendance link, should take that out. As soon as you've done that, open up number 3. So you can get a grade for today, following along live. Make sure you open that up. While you're at it, you might as well go ahead and open up the pre-programmed graphs because odds are we will use one of those today. If you're using Power School Learning, just go to chapter 4 and the instructions will apply. Oops, let me get there. Chapter 4 folder on the left side, and you will scroll down until you see lesson 4.3. And same instructions apply. After you take your attendance link, click here to open up the bell ringers and this for your pre-programmed graphs. Now I'm going to get started here on number 1. Oh, one more detail I'm going to throw in. The new thing I started adding here is this digital copy of the presentation to complete for notes. So I had some students talk to me that they have a writing tablet. And if you want to take notes and just save them to your Google Drive off the writing, I opened it up so you can have my full presentation slide by slide as you go through. And so if you want to write digitally and save your notes, you can follow along with that one. So this is like a new little ad under the digital resources right there. Okay, well, let's get started. So I'm going to take a look at number 1 here. It says a cable holds an 80-foot pole straight upright as shown. What is the approximate length of the cable rounded to the nearest foot? Okay, so remember the first 2 steps, anytime you're looking at a triangle here, the first step is to make sure your triangle is turned the correct way for us. And the rule was that the angles need to be on the x-axis. Angles on x-axis. Are my angles on the x-axis in this diagram?
Yes.
Yeah.
Yes.
So we had the 90 degree and the 62. And this time right here is going to be one of the last times you see me draw it. The y-axis technically should be over here. We're about to learn that with unit circles, why. But honestly, it can solve either way. Okay, so if you were to leave my class and immediately go across Skyline Building, walk into either Miss Lester's Calculus 1 class or Dr. Milana's Calculus 2 or BC Calculus class, you'll just notice the only thing they're going to do different is they'll put the y-axis on this angle, and we'll learn about that today. But either way, for solving, nothing changes. The pole represents the y value. This down here is the x value. And what do we call the cable, this diagonal slanted portion?
The hypotenuse.
Hypotenuse, that's our h. And so we learned, let me open up so I'm going to scroll down to spring semester and I'm going to open up the right triangle trigonometry. Basic trigonometry, that's right triangles, basic. I'm gonna open this up. Okay, and so what we've learned is we can solve, this is now step 2, what I'm entering into, step 2. We can solve by whatever the unknown variable is. We're gonna choose a trig function that has the unknown divided by the known. Now, you don't have to have it unknown divided by known, but it just is a shortcut if you do. So that's why I'm gonna write it that way. And so when you look at this problem, it says it's an 80-foot pole. So what I know is that the pole is 80 feet. So y is my known value. Well, what does it ask us for? Let's see here, the length of the cable. So that's what we're trying to find is the cable. This is the value we're trying to find right there. That's our unknown. So we're going to be looking for h divided by y. Okay, so I'm going to give you 5 seconds to here are the 6 trig functions, and you need to search out of these 6. Which one has h divided by y? Only one of them will. 5, 4, 3, 2, 1.
The DOL isn't open.
Okay, let me see if I can.
I think I was
Open it up.
the right one.
So I did the countdown. Lessons are open. Okay, so one more time. Which trig function should we use to find h over y?
Sin, the first one.
So I'm seeing, give me the letters. Okay, I'm looking in the chat. Pamela, you got it right. Give me the letters, because you might not know what the word is, but what are the letters? So far, I'm looking at the chat. I got 2 out of 3 correct.
Isn't it cosine?
So cosine is right here.
Oh,
And
no.
that one's cosine. Is this the one you're thinking? That's
No, CSC.
CSC, there you go. That's cosecant. Not that I expect you to have that memorized by any standards. If I did, I'd give you a little note sheet for that. But this one's called cosecant, but you can just tell me CSC. I'm fine with if you just say CSC. So CSC is the one we're going to choose because it's h over y. So those in the chat, good job. Who said CSC? The angle is always the x-axis angle. You're going to choose this 62, not the 90, by the way. So the x-axis angle that's not the 90, that's going to be right there, our theta. So cosecant of 62 degrees equals the unknown h divided by our known y, which is 80. And if you set it up this way, you're always one step away from solving. To get y by itself, or excuse me, h. Get h by itself. Right now it's being divided by 80. What's the opposite of dividing by 80?
Multiplying by 80.
So if I multiply, I should have switched colors here. If I multiply by 80, I'm able to use a proper math term, isolate my unknown. Now I have my h by itself. Let's go type this in the calculator. 80 CSC of 62 degrees. Answer is 90. I'm going to just round it. It says to the nearest foot. So does this stay as 90 feet or does it round up to 91 feet?
It should round up to 91.
That's right. We're going to round this up to 91 feet. So I'm going to do the approximately equals to sign, 91 feet. That's the length of the cable. Yes, and so I had a question, where is the graph? If you open up 4.3, it doesn't matter if it's PowerSchool Learning or Google Classroom, the list of graphs are in between number 3 and 4. The 3 being where we submit the bell ringers and all that, and 4 being your homework. I put it right in between there because that's when I figure you'll use it the most, is either in class or doing your homework. So that's why I throw that in right there rather than with the digital resources. Okay, so there's number 1. Let's now check out number 2. Number 2 says, if cosine is 3/5 and tangent is less than 0, what is the value of CSC? So let me come back to my calculator. So I'm going to fill in some values. Here's what I know about cosine. Cosine is x divided by h. This cosine is the same thing as x over h. So I can substitute there and say that x divided by h is 3/5. Because cosine is x divided by h, right there. Basic trigonometry rule right there. Tangent is y over x. So y over x is less than 0. And this says, what is cosecant? Which cosecant is h divided by y. That's what we're looking for. I could say, just use proper English. What is y over h? That's what I'm trying to find. Okay, so let's go through and solve this. I know x is 3, h is 5, which means right here, I could say this, that y divided by 3 is less than 0. So I just substituted. I took this and I'm going to plug that in right there. So I got y divided by 3 is less than 0. Now I don't know what y is, so I can solve for y right here. How do you get rid of a division by 3? We can
Multiply by 3.
That's right. And so if I multiply by 3, I find out that y is less than 0 times 3 is still 0. What this tells me is y is negative. So I'll put that in here. Y is negative. If you had Mr. Teresi, he does proofs all the time, and he does these 3 dots, which means therefore y is negative. Since y is less than 0, y is negative. But that's probably going to be a little confusing for us. I don't want to confuse it. So I'm going to take away the 3 dots. So I'll just put it in print, like a little bracket here as a note. Y is negative because y is less than 0. You cool with that? Okay, and over here for our answer, we can also substitute. We know h is 5. So I know that it's going to be 5 divided by whatever y is. It'll be negative, but we know that. CSC of theta will equal 5 over whatever our negative y value is. Okay, so how do I solve this? What I would recommend do is step 1, which is kind of like drawing our triangle. And what I do know is x is positive. So what I'm going to have is a positive x-axis. I'm going to label this as x. And right here, I discovered that y is negative. So if y is negative, I'm going to draw the y-axis going down like that. Okay. Do you have to have it drawn this way? No. But it might help us understanding if I draw it this way. I have a positive x of 3. So 1, 2, 3 units over. I'm going to have an x-axis triangle that's 3 units long. And we know our h is 5. So either way, the h has got to be longer. If this is 3, I'm going to assume maybe something like that is a 5 value. My hypotenuse is 5. So let's put that on a triangle. The x value is 3. The hypotenuse is 5. All we know about y is that it's got to be negative. So how can we solve for y?
Can we use Pythagorean theorem?
Absolutely. Whenever you deal with a right triangle or with ratios in trig, you always have a right triangle. So if you start seeing ratios, it's a right triangle, and we can use Pythagorean theorem. So I'm going to, for Pythagorean theorem, I use, instead of a squared plus b squared equals c squared, I use x squared plus y squared equals h squared, because it makes it easier to know exactly where to plug everything in. X is 3. Y is unknown. But my hypotenuse is 5. Okay, what is 3 times 3? 9. So 3 squared is 9. Again, we don't know why. What is 5 times 5? 25. Okay, we're trying to isolate the y here. So right now 9 is adding to y. What's the opposite of adding 9? We need to subtract 9 here. And let me cover up this blue so it's easier to see. Okay, so now I have y squared equals 25 minus 9 is 16. Okay, how do you get rid of a square?
Square root.
Square root. Okay, so the rule in math is anytime you add a square root that's not originally there, you need to have a plus or minus, which would mean we don't know if the answer is positive or negative, it just from this step. However, we learned over here that y is negative. So for that reason, I'm not going to do plus or minus. The square root of 16 is 4. I'm not going to do plus or minus 4. I'm just going to say y is negative 4, because y has to be negative because of this piece right here. So for that reason, we just learned that I'll have to write it over on this side. Negative 4 equals our y. So to get our answer, I come over here, and I'm just going to replace this with a negative 4. So the answer is CSC theta is 5 divided by negative 4. Okay, so that's how you would solve that problem there. It'll help as we go along. If you put to memory the Pythagorean triples is what they call it. So like a 3, 4, 5 triangle, and just because it'll save you this work, you'll just know. And then you can just go, okay, is it positive or negative? The value I'm missing, oh, it was a negative this time. So it's a 3, negative 4, 5 triangle. Okay, let's try number 3. It says find the length of the intercepted arc of a central angle of 60 degrees in a circle with a radius of 15 centimeters, round to the nearest tenth. So intercepted arc is another way of saying arc length. And as a reminder, what that means is you're measuring and from the radius or from the center of the circle around 60 degrees. So I'm just going to say 60 degrees is somewhere, that's 45. 45 is halfway between the x-axis and y-axis. 60 is somewhere in here. And it would help if I also drew these x-axis so you can see what I'm talking about. If that's the x-axis and that's the y-axis, and I'm going to do one little thing here so we can see our angle. Let me change this to where it's in the back. Send to back. There we go. Okay, so on this triangle, I want you to remember this is always the x-axis, this is the y-axis. Our angle here, what we just discovered, is 60 degrees. It tells us the radius is 15 centimeters, so r equals 15 centimeters. And by the way, just as this red line's a radius, so is this one. These two are both radiuses because the circle's the same distance away from the origin all the way around. So those would both be radiuses. The problem wants to know what's the arc length. And what that means, the intercepted arc is between here and here. What is that distance? And they use the letter S on lesson 4.2 when we taught this. It's just simple that early on in the day, they called this a radius. And so that's the letter R. They just chose the very next letter in the alphabet, S, for arc length. That's why they did an S there, if you're wondering, just because it comes next in the alphabet. So the formula was that S equals theta times R. It's the amount of radians times the degree. And then we had to change it. Said, okay, what if the angles in degrees? Well, you had to use that pi radians equals 180 degrees. And so on this problem, since we're in degrees, I'm actually going to have to change it from degrees to radians. So if you remember, to cancel degrees, you put the degree symbol down below and the pi symbol up above. So that right there is going to actually be the formula we use. The reason being is because this angle's in degrees, not radians. So I have to convert it to get a proper answer. So one more time, it's because if I want to find this distance, I need to be using units that deal with distance. Degrees doesn't do anything with distance, whereas radians is always a comparison between the arc length and the radius. That's why. So I need to change from a degree measurement to a length measurement of like radians. So for that reason, let's plug in our numbers and see what we get. So we'd have the arc length equals the amount of degrees, which is 60. Let me write it this way. 60 degrees times our radius, which is 15 centimeters, times, let me just use all x's, it'll be easier, pi over 180 degrees. The degree symbols would cancel each other out, and we'll see our unit's going to be in centimeters now. So I come over to my calculator. I'm going to type in 60 times 15 times, and the first time around, this is just 1 pi here. I'm going to get an answer in terms of pi, like we often do in calculus, and also I'll then round it as well. So I'm going to do it as 1 pi, or excuse me, 1 over 180. And I'm also going to type in this exact same thing. Computer slowed down on me. Come on, computer. There we go. With pi up top. And you can type in pi, and it'll automatically switch to pi. So we'll have our answers in both forms. So without the pi symbol, the answer would be 5, and then you have to add the pi symbol back. So it would actually be 5 pi centimeters. This length would be 5 pi centimeters. That's the exact answer right there. That's the exact answer. Now, if you want to round, that's when you put the pi in the calculator. And so the rounded answer is that S is, and it says round to the nearest tenth, that's 1 decimal place, it'll be 15.7. 15.7 centimeters. That's the rounded answer right there. So there's your bell ringer, and that's going to walk us into lesson 4.3, trigonometric functions on the unit circle.